everyone, and welcome to the 8th session of our U.S. Territories Wastewater Operator Training Series. Today, we're going to be going over operator safety, OSHA, and chemical safety. My name is Michelle Olson, and I'm a water utility trainer and specialist with the Southwest Environmental Finance Center here in Albuquerque, New Mexico. The Southwest Environmental Finance Center operates out of the University of New Mexico's School of Engineering, and this training series is funded by the U.S. Environmental Protection Agency. Before we begin, I'll let you take a moment to locate your control bar, and we'll just do a quick review. So the button labeled audio on the far left is for muting and unmuting yourself. So you want to make sure to remain muted during the webinar. You can unmute yourself if you want to ask questions at the end. You can also use the chat function to make sure or to ask any questions. If you post anything in the chat, make sure you send it out to everyone. Don't send anything directly to me, as I won't be checking the chat as I'm presenting. And if you need to leave the training, use the leave button on the far right. Our U.S. Territories Wastewater Operator Training Series is 26 sessions total, 1 hour each, and the trainers will vary depending on the topic. This is the schedule for the remainder of this year, 2025. So our next session will be in 2 weeks on Wednesday, October 15th, and we will be going over preliminary treatment. Recordings of our sessions and copies of the material are also available on our website. All right, let's begin. So as wastewater operators, it's important to keep safety foremost in your minds when you're on the job, because safety is paramount. You're going to be faced with work situations that include safety hazards, some of which will be obvious, some of which aren't. So we want you to be aware of safety issues and make sure that you keep yourself, your coworkers, and your community safe so that you can have a long and prosperous career in the wastewater treatment field. Before I started working here with the Southwest Environmental Finance Center, I was with the New Mexico Environment Department in the Drinking Water Bureau. And at the office I worked out of, we sat in cubicles. So I don't know if you've ever been in a cubicle, but you can hear everything everyone around you saying. Well, we had to share a floor with New Mexico OSHA, so I had to listen to them on the phone all day long. We have like just over 2 million people here in the state of New Mexico, which isn't that many people compared to places like California or New York. But I overheard a lot of horrible stories every day about workplace injuries and even fatalities. It really opened my eyes to how serious workplace safety is. So you may think something bad won't happen to you at work, but it absolutely can. So you need to know how to be safe on the job. As you do your work, you should view your surroundings with your hazard eyes on. Every workplace has some risk of injury. We can't cover every safety issue in this training, but we do want to highlight some critical areas that you should be familiar with. When we look at wastewater operations, there are a few categories of hazards that you need to be aware of, including chemical hazards. Chemical hazards include exposure to toxic or harmful substances that are used in treatment processes. These can be acids and bases, amongst other things, and they could lead to injury. So injuries associated with chemicals can come from acute exposure, meaning that coming into contact with it just once is all it takes, excuse me, to injure or kill you, or long-term exposure, which is contact over many years. And this is serious because at first you feel fine and you don't see the effects it has on you until it's too late. So injuries associated with chemical hazards include burns, poisoning, respiratory problems, paralysis, even death. Physical hazards are those that cause immediate and traumatic injuries, such as accidents that involve getting caught, pinched, or crushed in machinery, improper lifting and slipping, fire and explosions, falling, as well as noise from machines that can result in hearing loss. So not all injuries are life-threatening, but they can impact your life nonetheless. Hearing is one of your senses, and when it's damaged, you don't get it back, not in the way you had it before. And I think we have a tendency to normalize hearing damage. It's like, how many times have you heard someone say, like, I don't need ear protection, my hearing's already damaged. Well, even if that's the case for you, protect what you still have. Biological hazards are exposure to waterborne pathogens that cause disease. These are common in wastewater and include those protozoans, bacteria, and viruses that we treat for that cause infectious disease or illness when we're exposed to them. Hmm. Infections or injuries we sustain when our bodies are exposed to pathogenic microorganisms. Environmental hazards are dangers associated with the work environment itself. They involve risks associated with confined spaces, drowning, being trapped or engulfed in the ground, dangers associated with working near traffic, and exposure to the elements. Other hazards include radiologic hazards, like radiological waste from the healthcare industry or exposure to UVs, which is a commonly used disinfectant in wastewater, electrical shocks from equipment or working near power lines, and any number of known and unknown hazards that aren't covered here. Of course, the purposes of this isn't to scare you away, but to make sure that you take the risks seriously and help create a safe work environment. As always, look at your area-specific regulatory programs to understand the requirements. Some rules may be stricter in your jurisdiction than they are in others. And if you want to learn more about wastewater safety, much of Sacramento State wastewater programs' Operation of Wastewater Treatment Plant Manual is devoted to safety. In fact, they have an entire chapter devoted to safety, and each section dealing with treatment processes has a safety section, so check it out. It's management's responsibility to provide a safe place of employment. However, if they don't know about a safety issue, then they can't take appropriate action to address it and create a safe work environment. It's the operator that has the primary responsibility for their own safety. It's your life and it's your well-being on the line. You're ultimately the one responsible for your own safety. So if you see a situation that's unsafe, you need to let others know so that it can be handled before someone's hurt. Don't be a headline because nobody wants to be a headline. I'll be careful. How many times have you said that knowing you're about to do something dangerous? People are bad at assessing risk, overconfident in outcomes, and tend to think that they're the exception. Climbing onto a rolling chair to change a light bulb is dangerous, except when I do it because I'm careful. No, this is especially true when there's an emergency. So this is a story about a construction supervisor who entered an oxygen deficient manhole and collapsed. Two others, a foreman and another supervisor, went into the manhole to rescue him and they also collapsed. All three died. I've heard so many stories about workers who entered an area that was filled with hydrogen sulfide or walked onto electrified ground and collapsed. And then another coworker, without thinking, just ran into that situation to save them, not understanding what the danger was, and also collapsed. These stories don't end well. This is why there are standard operating procedures, personal protection equipment, and safety training to make sure we do the right thing in these serious situations. So if you find yourself in an emergency situation, take the time to follow safety protocol so you don't become a victim yourself. It's really important that you as operators recognize the safety issues that you may face in each situation. They'll vary, and as operators, particularly when you're working for a small system, you've got to be a jack of all trades. You're responsible to yourself, your employer, and your coworkers, your community, and the community downstream of you. Did you know that most injuries are caused by the injured employee? That means that personal protection equipment, a safety program, and training could make that injury preventable. All right, so we're going to do a quick poll. All right, so operators can experience physical injuries caused by moving machinery, improper lifting, slippery surfaces, or all of the above. So I'm going to give you about a minute to answer this question. Operators can experience physical injuries caused by moving machinery, improper lifting, slippery surfaces, or all of the above. All right. Going once, going twice. Let's see the results. All right, operators can experience physical injuries caused by all of the above. Looks like you guys all got it. Good job. So yes, moving machinery, improper lifting, and slippery surfaces can all cause injury. All right. So before we talk about safely working in a wastewater environment, let's take a few minutes to talk about how workplace safety is regulated in the United States. At the federal level, the implementation and enforcement of occupational safety and health regulations falls under OSHA. That's the Occupational Safety and Health Administration, which is part of the US Department of Labor. The administration was created in late 1970 when President Nixon signed the Occupational Safety and Health Act. This act covers most private sector employees and their workers, in addition to some public sector employers and workers in the 50 states and in certain US territories and jurisdictions under federal authority. Of course, there are a lot of different kinds of legal entities that run wastewater treatment facilities. Some are private, some are public, but as an operator, you're responsible for having a basic understanding of the regulatory environment in which you're working. I also want to note that although we're showing the OSHA logo, this is not an OSHA sponsored or supported webinar. OSHA's mission is to assure safe and healthy working conditions for working men and women by setting and enforcing standards and by providing training, outreach, education, and assistance. Occupational Safety and Health Act covers most private sector employers in all 50 states, the District of Columbia, and other US jurisdictions, either directly through federal OSHA or through an OSHA-approved state plan. In some jurisdictions, state agencies have taken on the responsibility for enforcing occupational health and safety. Those approved state programs effectively take the place of OSHA, but are approved, monitored, and partially funded by OSHA. The following 22 states and Puerto Rico have OSHA-approved state programs. State and local government workers aren't typically covered by federal OSHA, but have protections if they work in a state with an OSHA-approved state program. 5 additional states in the US Virgin Islands have OSHA-approved state plans that cover public sector workers only. And these are those states. Be aware of your local occupational safety and health regulations. So not all states or US territories have OSHA-approved programs implementing the federal OSHA regulations. Most, if not all, states have their own agencies that regulate occupational safety, and their regulations or recommendations may, in some cases, be more stringent than OSHA's. The good thing is those kinds of differences will typically be pointed out in state-specific testing and study materials. So let's talk a little bit about safety programs, because safety is everyone's concern. According to OSHA regulations, all wastewater utilities, regardless of size, must have a safety program to systematically address workplace safety and health hazards on an ongoing basis to reduce the extent and severity of work-related injuries and illnesses. That's an OSHA quote. And while this may be the requirement, it's not always met. So a good safety program should identify the cause of accidents, illness, and injuries, provide safety training, implement an accident reporting system, and hold supervisors responsible for implementing the safety program. That last one's important because if only employers or a safety officer are held responsible, the program's likely to fail. As operators, you've got the most to gain because you're most likely to be injured. You should ask about your employer's safety program and participate in it, get involved. Follow safety protocols and standards when you're doing your job, even if they take a little bit longer. Use your safety equipment like SCBA, hard hats, goggles, gloves, other personal protection equipment. And you want to report safety hazards and injuries. So that last bullet's important. If you see something, say something. When it comes to safety, it's management's responsibility to develop a written safety statement and establish a safety program, align responsibilities for injury prevention, appoint a safety officer or coordinator, establish realistic safety goals and revise them to encourage continual improvement, and evaluate safety program results. That last point is crucial. The only way to know something is effective is if you track and measure the outcomes. This is why all injuries should be reported and why we have reporting programs in the first place. When it comes to a safety program, there should be 3 training components. 1, safety education of all employees. 2, reduced education in safety or reinforced education in safety. And 3, safety education in the use of tools and equipment. So to put it another way, education, education, education. Safety is not a once and done kind of thing. Education can come in the form of safety orientations for new operators, ongoing training and safety reinforcement, particularly with job duties as they're learned. There are different considerations for different situations, and there will be specialized training required for working in confined spaces, water-filled structures, and other hazard areas. Tailgates aren't just for parties and barbecues at the game. They're a great place to have safety meetings. Tailgate meetings can be a part of an ongoing safety training or the start of work at a new job site. These meetings make sure everyone is on the same page, that safety is foremost in everyone's mind, hazards are identified, and it gives everyone the opportunity to ask questions. This is the hierarchy of controls to safety to control hazardous workplace situations, and it can be applied to safety in the wastewater workplace. The least effective measures are at the bottom and the most effective measures are at the top. So starting at the top, the most effective control on workplace hazards is elimination. That means physically removing the hazard. This could look like removing non-functioning equipment or performing tasks at ground level instead of from an elevated position. Substitution, that's replacing the hazard, like using automatic sampling instead of manual sampling. Next are engineering controls. So these are controls that isolate people from hazards like rails or guards. Then we have administrative controls. So this is changing the way people work through the implementation of safety training programs, things like that. And finally, we have personal protection equipment. So this may sound surprising because when we talk about safety, we tend to focus a lot on personal protection equipment. So those are our safety glasses, hard hats, protective shoes, and gloves. But in reality, these are the least effective controls. They're the last line of defense against workplace injuries, and it's what we rely on when all other safety controls have failed. But just because they're the least effective doesn't mean you shouldn't use them. They still protect you. All right, let's do another poll. Okay, who has the most to gain from a safety program? Management, office staff, operators, or supervisors? So I'm going to give you about a minute to answer this question. Who has the most to gain from a safety program? Management, office staff, operators, or supervisors? I'll give you another 15 seconds. All right, I'm going to end the poll and we'll see what the results are. All right, so it looks like most of you say that operators have the most to gain. And yeah, operators, you're the ones who are most likely to be injured. So everyone benefits from a safety program, but it's the frontline employees that benefit the most. One of the hazards we have in working in a wastewater environment are infectious materials. Many microorganisms can cause illness, including bacteria like cholera, which is pictured in the background, protozoa, helminths, which are parasitic worms, and viruses. So it's a good idea to assume that all the surfaces you come into contact with are contaminated. You want to talk to your safety officer about inoculation for typhoid, paratyphoid, polio, hepatitis A and B, and tetanus. When dealing with infectious material in wastewater, be sure to use personal protection equipment like gloves anytime you handle hazardous samples or anytime you may come into contact with wastewater or sludge. And wash your hands frequently and well. If COVID did anything, it really taught us how to wash our hands properly. Working in a wastewater environment, you should be aware of water safety and creating an environment that mitigates this hazard as much as possible. You want to reduce slip hazards on catwalks around clarifiers and basins. Use extra caution when you're working in wet or icy weather. Keep handrails in good repair and replace any damaged handrails. You want to mark and guard unsafe areas with guardrails, rope, chains, or cable. And you want to station emergency gear near filters, tanks, basins, and clarifiers. These include safety vests, buoys, and life poles. And you want to learn how to swim, but also use a personal flotation device where appropriate, even if you can swim. All right, we're going to do another poll. If you fall into an active aeration basin, you will always be able to swim out. So yes or no? And I'll give you a minute to answer this question. If you fall into an active aeration basin, you will always be able to swim out. Yes or no? All right, I'll give you another 10 seconds. Will you always be able to swim out of an active aeration basin? Yes or no? All right, I'm going to end the poll. And let's see the results. So it looks like most of you say no. And that's correct. Aeration tanks involve more danger due to aeration mixing equipment and currents in the tank. In addition, aeration reduces buoyancy and it makes it difficult to stay afloat. So if those blowers are going at full blast and you aren't wearing a personal flotation device, there's a good chance you're going to sink like a rock. There was a Mythbusters a long time ago where they looked at this question about staying afloat in an aeration basin, and they found that even with a personal flotation device on, it's really difficult to swim if those blowers are going at full blast. In a wastewater treatment plant, there are also a lot of electrical hazards. And as we know, electricity and water don't mix. Utilities have equipment with a wide range of voltages, 120, 220, 440, up to the kilovoltage range. These include transformers, starters, motors, instrumentation, and control panels. So another poll, oh wait, let me launch it first. Okay, can 120 volts kill you? Yes or no? I'll give you a minute. Can 120 volts kill you? Yes or no? Just for reference, most outlets in homes in the United States are around 120 volts. All right, I'll give you another couple seconds. If anybody wants to throw in a last minute answer, can 120 volts kill you? Yes or no? Okay, I'm going to end the poll. Let's see. Most of you said yes. Let's take a look. So yes, 120 volts can kill you. It only takes 12 volts to injure you. So let's look at a couple of examples. First, you should be familiar with how currents and voltage are related. Ohm's law tells us that current equals voltage divided by resistance. Another way to write this law is amps equals voltage divided by ohms. So you've probably heard the phrase, it's the amps that kill you. Well, it only takes 1 amp of current to kill us. So let's put Ohm's law into practice and see what happens when our bodies are shocked with 120 volts. When we talk about resistance in the human body, ear to ear, we have about 100 ohms of resistance. That's not a lot of resistance ear to ear. Our hand to foot resistance is 500 ohms. Skin. Dry skin has a lot more resistance than wet skin. Dry skin is around 300,000 ohms, while wet skin is around 1,000 ohms. So if you have wet skin, all that resistance is going to go down. This includes if your skin is sweaty, which I'm sure you never sweat while you're at work, right? Remember, resistance in the body ear to ear is 100 ohms. What happens if we're shocked ear to ear with 120 volts? So we have Ohm's law. Let's go ahead and plug these numbers into our equation. We divide 120 volts that are shocking us by the 100 ohms of resistance in our body, and this gives us 1.2 amps of current running through our head. Remember, it only takes 1 amp of current to kill us. So in this case, the outcome at 120 volts is going to be instant death. Let's look at another example. Resistance in the body hand to foot is around 500 ohms. What happens if we're shocked hand to foot with 120 volts? So let's plug these numbers into our equation. 120 volts divided by 500 ohms of resistance gives us 0.24 amps or 240 milliamps of current. In this case, the outcome at 120 volts is going to be severe burns and possible death. So when we work with electricity, we want to follow some basic safe electrical practices. We want to be proactive in our maintenance to identify performance and safety issues with our electrical equipment. We want to use non-conductive tools when working around electricity. We don't want to use electrical equipment with worn or frayed cords. Permanent wiring should be installed with conduit or armored cable by an electrician. We want to replace connections with worn or thinning insulation. We want to make sure to ground that equipment with 3-pronged plugs. We need to be alert for any equipment that's overheating or if you get a tingling sensation while you touch it. Make sure that any electrical units that are operated in areas exposed to flammable vapors are explosion proof. And it's important to work in pairs to service, repair, or troubleshoot electrical equipment. One of the best ways to avoid accidental electrocutions and equipment accidents is by using a lockout and tagout procedure. The basics of lockout and tagout programs include notifying affected employees that the lockout tagout procedure will be used and why, shutting down equipment using normal shutdown processes or procedures. Then we isolate the equipment from the energy source and ensure that any stored energy is dissipated. For example, when we're working with capacitors or starters, we need to make sure that they're all de-energized. Then you want to lock out and tag out the energy isolating device, usually a breaker, with the assigned individual. After you lock and tag, confirm that the circuit's dead. Ensure the energy source is disconnected after ensuring no personnel are exposed. Now the work can begin. After the work is complete, all the tools are removed and everything's returned to working order. After we've ensured all employees are clear, we remove the lockout and tagout devices. Then we can notify affected employees that lockout and tagout have been removed and restore power to the equipment. All right, another poll. Who should remove locks and tags from electrical equipment? The operator who needs to use the equipment next, the operator who locked and tagged out the equipment, any operator that's qualified as an electrician, or any operator on the next shift. So I'll give you a minute or so to answer this question. Who should remove locks and tags from electrical equipment? The operator who needs to use the equipment next, the operator who locked and tagged out the equipment, any operator that is qualified as an electrician, or any operator on the next shift. I'll give you another 10 seconds or so to answer this question. Who should remove locks and tags from electrical equipment? All right, I'm going to end the poll. Let's see what you guys had to say. So it looks like most of you said the operator who locked and tagged out the equipment. And that is correct. All right. You never want to remove lockout and tagout equipment that someone else installed unless your employer has specific procedures and training for removal by others. All right, there are a lot of potentially dangerous chemicals in a wastewater treatment plant that can, if handled incorrectly, cause accidents and cause exposures with acute and chronic effects. It's a good idea to understand the chemistry of substances you're working with, how to store them, use them safely, and how they could potentially affect you and others, and what to do in the event of an exposure. Knowing characteristics like boiling point, flammability, explosive limits, reactivity, and first aid for each of the chemicals that you work with is important. Some of the chemical hazards that you may experience with wastewater treatment can cause burns, respiratory damage, eye damage, rashes, skin damage, headaches, and even death. Chemical hazards can cause both acute and chronic health effects. Acute effects occur with chemical contact, and they usually resolve when no longer in contact with medical treatment. So this includes things like eye irritation and blurred vision from chlorine exposure that may clear up when you're in fresh air. However, not all acute effects are reversible. Chronic effects are long-term effects that may not appear immediately or after a single exposure. These effects may or may not be reversible. For example, coughing and wheezing from long-term low-level exposure to chlorine. Take note that chemical hazards can have acute effects, chronic effects, or both. Some hazards have immediate impact, while others will creep up on you through repeated exposure. Acids get used a lot in treatment processes and for cleaning. They can react violently if exposed to alkali materials like ammonium nitrate or potassium hydroxide. Personal protection equipment like splash-proof goggles and a face shield are a must when working with acids. Bases are typically used to raise pH in a treatment plant. They can attack human tissue quickly and cause burns. They can have an explosive reaction when they come into contact with acids. Some bases, like quicklime, won't explode but generate a lot of heat when mixed with water. So splash-proof goggles should be worn at all times due to the strong hazards bases present to eyesight. Here are some other chemicals you're likely to encounter with wastewater treatment: chlorine, methane, hydrogen sulfide, other gases, alum, activated carbon. Since so many different chemicals are used in wastewater treatment and throughout multiple different industries, there has to be a common method for identifying and communicating chemical hazards. In the United States, the system is referred to NFPA 704, which is the standard system for the identification of the hazards of materials for emergency response. And you need to become familiar with how they work. So it's a grid of 4 diamonds, and you typically see this on the back of like 18-wheelers if they're transporting chemicals. So it's a grid of 4 diamonds, and on the left we have a blue diamond, and that represents the health hazards. So there will be a number in this diamond from 0 to 4. 0 means that it's normal material, and then 4 means that it's deadly. So that's the range. At the top, we have a red diamond, which represents fire hazards. So again, there will be a number in that diamond from 0 to 4. 0 means it's not flammable, all the way up to 4, which means that it's a fire hazard below 25 degrees Celsius. On the right, we have a yellow diamond that represents the reactivity. Again, there will be a rating from 0 to 4, where 0 means it's stable and 4 means that it may detonate. And then at the bottom in the white diamond, those are the specific hazards. So that'll tell you if the chemical is an oxidizer, an acid, an alkali, if it's corrosive, radioactive, or if you shouldn't use water on it in an emergency situation. OSHA also has the Hazard Communication Standard, HCS, which requires pictograms on labels to alert users of the chemical hazards to which they may be exposed. Each pictogram consists of a symbol on a white background framed with a red border, and it represents a distinct hazard. The pictogram on the label is determined by the chemical hazard classification. Safety data sheets. Safety data sheets are all set up the same way, and at a minimum will have these sections. The first section identifies the chemical name. So in this example, the chemical is sulfuric acid. It will tell you the intended use and the supplier's contact information. So this helps in correctly identifying the chemical and knowing whom to contact in case of emergencies. The second section identifies the hazards associated with that chemical, including the classification of hazards, hazard statements, the pictograms that we just talked about, and signal words like danger or warning. So this will give us a clear understanding of the risks associated with that chemical, so we can make informed decisions regarding safety measures. The third section is the ingredients in that chemical, and that includes impurities or additives along with their concentrations. So in this case, it's 90 to 98% sulfuric acid and 2 to 10% water. So this helps us understand the chemical's potential interactions and specific hazards of each of the components. The fourth is the first aid measures. So these are the instructions for initial treatment in case of exposure. It includes first aid actions, which provide immediate guidance to help mitigate health effects during emergencies. The fifth section is the firefighting measures that need to be taken, including extinguishing methods, potential fire hazards, and protection equipment needed for firefighters. This is important information for first responders to ensure effective and safe response to fires involving chemicals. Not all chemicals should have water put on them, for example. So this will let them know. Section 6 is the accidental release measures. These are the procedures for contaminant cleanup and disposal in case of a spill or leak of the chemical. This helps minimize the environmental impact and reduce exposure risk. Section 7 is handling and storage. These are the safe handling practices and storage conditions you want to use to help that chemical stay stable and to prevent hazardous situations. Section 8 is exposure controls and personal protection. These are the occupational exposure limits, engineering controls, and the recommended personal protection equipment that you want to be using when you handle this chemical to minimize your risk of exposure. The 9th section is physical and chemical properties. This is information about the chemical's appearance, its odor, pH, melting and freezing point, other physical characteristics. This can help you identify the chemical and understand its behavior under various conditions. Section 10 is stability and reactivity. This is the chemical stability, conditions to avoid, and incompatible substances to prevent hazardous reactions and maintain chemical integrity. Section 11 is the toxicological information. So these are the health effects, routes of exposure, symptoms, toxicological data, which outline the potential health impacts and necessary precautions you should be taking. Section 12 is the ecological information. These are the effects that the chemical has on the environment, such as toxicity to aquatic life, its persistence or how long it lasts in the environment, bioaccumulation, those kinds of things that help guide measures to protect the environment from the chemical hazards. Section 13 is the disposal considerations. So how to safely dispose of this chemical and its container so that you are conducting in an environmentally responsible manner and that you're compliant with disposal practices. Section 14 is transportation information. So this includes the classification for transportation, UN number, shipping name. This helps, facilitate the safe and regulated transport of hazardous chemicals. Section 15 is the regulatory information. So the relevant safety, health, and environmental regulations. So to help ensure that you're in compliance with any legal requirements that might apply to that chemical. And the final section, section 16, is other information. So this is who put the SDS together, the date it was prepared or last revised, any disclaimers and references in order to provide additional context and help you ensure that the SDS is up to date. So for any chemical you work with, you want to read through and familiarize yourself with these safety data sheets. You don't want to wait until you have an accident to start reading the safety data sheets. And for each and every chemical that you work with, you should read through the SDS before working with that chemical. Store the SDS in an accessible location near where the chemical is being used so you can refer to it quickly if you need to. All right, let's talk about chlorine. So chlorine is a chemical that's commonly used in wastewater treatment, so you should be familiar with its properties and its hazards. You don't want chlorine in your eyes or in your lungs. Mishandling chlorine can kill you. Here's a table that shows the health effects of chlorine exposure based on how much of it's in the air. The values in the column on the left are in parts per million, and the bolded row at the top is the OSHA ceiling limit of 1 part per million. Now, the National Institute for Occupational Safety and Health's recommended exposure limit is half of that as a weighted average for a 10-hour workday. Most people can detect chlorine at low concentrations, but chlorine will also deaden your sense of smell, so you may not notice it after a while. And since this is so commonly used, let's use chlorine as a framework and example for talking about safety equipment. It's important that you know the safety equipment that you have at your utility. This includes where it's stored, so you can get to it quickly and easily in an emergency, how to use it properly so that it provides you with the maximum protection, when to use it. This includes knowing which situations are appropriate for its use and which are not, because as we'll see, not every piece of safety equipment works in every situation. And you want to know how to properly maintain it so that it's in good working order when you need it. A respirator like this just filters out chlorine gas and it protects your eyes. So if you're in an area and there's a chlorine leak, you have the personal protection equipment you need to get out of there right away. But you should never go into an area where there's chlorine gas present with a canister gas mask. This kind of personal protection equipment is for escape purposes only, because what's not in the room can kill you just as easily as what is in the room. Chlorine gas can displace the air in a room. So if the oxygen levels drop below 12%, you could die. There's not going to be enough oxygen to sustain you, even though the chlorine is all getting filtered out by the gas mask. This is the reason why you also never want to crawl out of a room where there's a chlorine leak if you can avoid it, because chlorine is heavier than air and it will sink to the floor and it'll displace the oxygen that's there. So if you were in a structure fire and the room was filled with smoke, you'd want to hit the floor and crawl out because, smoke rises. But that's not the case with a chlorine gas leak. By going to the floor, you may be actually putting yourself in an oxygen depleted area and you may pass out before you realize the danger. Again, this is about knowing what to do in a given situation, what equipment to use, and how to use it. Also, a side note, all personal protection equipment should be maintained. Chlorine gas mask canisters have to be changed every 6 months or when they're exposed to chlorine. So this is the sort of maintenance that a safety program should cover. An SCBA, that's self-contained breathing apparatus. So an SCBA system provides you with an air supply and it blocks the chlorine for a limited time. But they take training to use, they require maintenance, and you can't have facial hair that gets in the way of the mask seal. They must also be stored outside of the chlorine room, so you don't have to go into the chlorine to get to the SCBA. Poorly maintained or located personal protection equipment and rescue equipment can be worse than none because you may have a false sense of security without really understanding the risks associated with it. And now let's talk about confined spaces, another hazard that's common with wastewater systems. All confined spaces have the following in common. They're large enough and configured so that an employee can bodily enter and perform work. They have limited or restricted means of entry and exit. They're not designed for continuous occupation. And every entry into a confined space requires a confined entry space permit to ensure that a supervisor or other qualified person has taken the appropriate safety measures prior to entry. Some examples of confined spaces in wastewater include tanks, manholes, vessels, storage bins, pits, and vaults. Hazards associated with confined spaces include air contamination. Air contaminated with other chemicals may be flammable, explosive, or toxic. Or there may be the presence of explosive chemical dust. The air in confined spaces may be oxygen enriched, which increases the risk of explosion. Or it could be oxygen deficient. As we've said, oxygen deficiency can be as deadly as being exposed to a toxic gas. So let's look at a few facts about oxygen. Normal air is made up of 20.9% oxygen. So that's the condition our brains need in order to operate at their best. We're in potential danger when oxygen levels drop below 19.5%. That's less than 1.5% drop from normal conditions. So there's not a whole lot of wiggle room there. At 17% oxygen, we start experiencing a shortness of breath. When oxygen drops between 10% to 6%, we'll rapidly lose consciousness. And below 6% oxygen, death occurs within minutes. Some common causes of oxygen deficiency in confined spaces are bacterial action using up the available oxygen, displacement of oxygen by other gases, like we had talked about. So these could be toxic like chlorine or hydrogen sulfide, or they could be inert like nitrogen. Oxidization of other metals or other materials will deplete the oxygen levels. Oxygen can get absorbed into the surfaces, or it can be lost through combustion. Manholes are confined spaces. They have limited openings for entry and exit. They also have unfavorable natural ventilation. So deadly gases can accumulate and oxygen can be displaced. So they require air quality to be monitored, and they require ventilation. And corrosive gases in the sewer can cause steps to deteriorate, so be careful in there. Remember, manholes are not designed for continuous worker occupation. With wastewater systems, you run into confined spaces all the time during maintenance, so you want to follow the regulations and standard operating procedures to stay safe. Multi-gas monitors, confined space entry checklists, and permits are your friend. Note that exact procedures for confined space entry can vary between agencies and locations, so confirm the local rules with the appropriate regulatory safety agency in your area. Finally, let's talk about excavation hazards. When there is a collapse in a trench without adequate cave-in protection, there's usually no warning and there's no time to escape. OSHA requires cave-in protection when a trench is more than 5 feet deep. While many of us are probably taller than 5 feet, our chests probably aren't. So if there's a cave-in, it may not cover your face with dirt, but it will encompass your chest. And that pressure can prevent you from being able to take a breath, even if your face isn't buried. New Mexico Environment Department recommends protection for excavations 4 feet and deeper. So this is just a reminder to check with your local requirements. There are 3 basic ways to protect trenches from cave-ins: shoring, shielding, and sloping. Shoring uses a framework to press against the walls of the trench, usually using a hydraulic or pneumatic piston, and so that supports the walls of the excavation and prevents soil movement. Shielding is done using a 2-sided steel trench box, and it's there to protect the workers inside of the trench in case of a collapse. It's not there to support the walls of the excavation like in shoring. So the key to staying safe with these is staying inside the box between the 2 plates. So if you notice in that picture, the person in the middle is not between the plates. So that is not a safe place to be if there's a collapse. In addition, you don't want any big gaps between the trench wall and the trench box. If there are, and there's a cave-in, the trench box could collapse. And last but not least, we have sloping, which is what's going on in this picture, where the sides of the trench are sloped in a manner to reduce the likelihood of a cave-in by removing the trench wall itself. The acceptable slope angle is 37 degrees, or a slope of 1.5 to 1, which is the run over the rise. That means that you need 1.5 foot of horizontal excavation for every 1 foot of vertical on both sides of the trench. That may be hard to visualize. So in this example, if we have a 5 foot deep trench, we will need 7.5 feet of run on each side of the trench to effectively remove the trench wall. This means that you need to have an excavation that's 15 feet wide plus the width of the trench, not to mention the space to put the spoils. So as you do the math in your head, you can quickly see why other options may be more cost effective, and in some cases, they may be the only option possible. Ladders. Ladders are required every 25 lateral feet. They must extend at least 3 feet above the excavation wall, and they need to be placed on firm ground within the trench. Again, don't be a headline. Nobody wants to be a headline. So every one of these accidents listed happened because the workers in question weren't following the rules, didn't use adequate protection, and in almost all cases, the person who was trapped died. As we said at the beginning, people are often bad at assessing risk and overconfident in outcomes, particularly when prior risky behavior hasn't led to negative consequences or when there's an emergency. This is why there are standard operating procedures and personal protection equipment and safety training to help make sure we do the right thing in these situations. Please be aware that there are a lot of other hazards that we didn't cover today. You want to make sure to study available materials for your program and your regulatory agency. You want to follow safety programs developed by your employer. And most of all, use your head, because you're the one who has to live with the consequences of your actions. All right,